Alright, here we are with 4.7 inverse trig functions. Recall that for a function to have an inverse, it must be 1 to 1, and it must pass the horizontal line test. Okay, from our sine and cosine graphs, we know that those won't pass the horizontal line test because they keep bouncing up and down. So what we do with our sine and cosine functions here is just look at the first little piece. We're only going to look at this first little piece from bottom to top. And that's how we're going to be able to look at this and get an inverse, because here it is, it passes the vertical line test and it also passes the horizontal line test, so we know we will be able to have an inverse. On the interval negative pi over 2 to pi over 2, it's increasing the whole time. It takes on the full range of values from negative 1 to 1, and it is also 1 to 1. So that's why we look at that particular interval. Some other notations you might see for inverse: you might see arc sine, and you might see the negative 1 notation. The notation sine to the negative 1 of x is consistent with the inverse function notation f inverse of x. The arc sine notation comes from the association of a central angle with its intercepted arc length on the unit circle. So arc sine of x means the angle or arc whose sine is x. So here we have the inverse sine. So if we look at it from here, it's going from negative pi over 2, comma, negative 1. So to do your inverse, you flip x and y. So this is going to be negative 1, comma, negative pi over 2. You're just going to make this little squiggly that way. This one goes up to pi over 2, comma, 1. So this one's going to go up to 1 over, comma, pi over 2 up. So you're really thinking about what value gives us these answers. So knowing that unit circle is going to be very helpful. So, arc sine of negative a half. That's saying sine of what theta equals negative a half. Okay, so I like to draw a picture. Negative a half. Okay, so sine at negative a half, that's going to be at negative 30 degrees or negative pi over 6. Sine inverse of radical 3 over 2. We have radical 3 over 2 way up here. Remember, sine is your y-coordinate. So we're talking about 60 degrees or pi over 3. And then where does sine inverse, what's the sine inverse of 2? Where does sine equal 2? Trick question. It doesn't equal 2. Sine bounces back and forth between 1 and negative 1. No solution. Undefined. Alright, sketch a graph of arc sine. I'm not going to do that. If you wanted to, use your graphing calculator. You need to make sure you're in radian mode. And use second sine. To graph that. Okay, cosine. Y equals cosine of x. Again, we're going to pick a very particular interval so that it stays 1 to 1, so that it passes the vertical line test and passes the horizontal line test. So we're going from here to there, top to bottom. for the same reasons as we did the sine one there, just to make sure that, because if we did all of it, okay, it's not going to pass the horizontal line test, so it's not going to have an inverse. So we're just going to pick a very particular interval and then apply that interval using our quadrant rules there to find other answers that would not be part of that. Okay, let's see. Nothing that important. Let's get to the real stuff here. We're going to be doing some finding of values. Again, I'm a unit circle fan. So I draw a unit circle. So where is cosine, arc cosine of radical 2 over 2, aka where does cosine equal radical 2 over 2, positive radical 2 over 2? And again, we're talking about 0 to pi for our one particular interval. Okay, so then we're going to have that at pi over 4 or 45 degrees. Where does cosine equal negative 1 at? Negative 1, 0 over here. And that is in our top half that we're looking at. And that will be at pi, or 180. Arc tangent of 0. This is a tricky one. Arc tangent of 0. So where does tangent equal 0? Remember, tangent is sine over cosine. Okay, so we want where does sine equal 0 that fits in the arc tangent one. Because if sine is 0, 0 divided by something else is going to be 0. We don't want cosine to be 0 because we don't want 0 on the bottom. Okay, so where does sine equal 0? And remember, sine is on the right half. So we're looking at 0 degrees or 0 pi. Tan inverse of negative 1. Okay, that is where would, and tangent is the same one as the sine. It's on this half. Where would sine and cosine be the same thing but opposite signs? Well, we know at the pi over 4 is they're going to be the same thing but possibly different signs. Here they'd be positive, positive. That's not going to work. So here it is, negative pi over 4. They would be radical 2 over 2, comma negative radical 2 over 2. All right, composite functions. Recall that for all x in the domains of f and f inverse functions have these properties. F of f inverse of x cancels out and equals x. F inverse of f of x cancels out and equals x. So sine of arc sine going to cancel out. Arc sine of sine cancels out. Okay? Again, just because we have room here, cosine inverse or arc cosine is on the top half. Arc sine and arc tan are on the right half. Alright, so tangent of arc tangent of negative 5. Inverses cancel out. And we have negative 5. Arc sine of 5 pi over 3. This is a tricky one. So 5 pi over 3, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi over 3. So if you are talking arc sine, remember arc sine is only over here, so we can't really go with 5 pi over 3. We're going to have to go with the negative pi over 3 to get there. So that's a tricky one, so that's going to be negative pi over 3. cosine of cosine inverse of pi. Also, a tricky one here, not defined, because think about what pi is. 3 point something. When does cosine equal 3? It doesn't. Okay? So that's another little tricky one there. Okay. Finding the exact value. Cosine of arctan of negative 3/4. Okay, so arctan is in the right-hand side. Negative 3/4 means we're going to be down here. Tangent is negative 3/4, so down 3 over 4, 3, 4, 5. What's cosine going to be? 4/5. Okay, sine of arc cosine of 2/3. Okay, arc cosine's the top half. It's positive. So 2/3 adjacent over hypotenuse. Okay. We need to do a little a squared plus b squared equals c squared. So it's going to be radical 5 over here. So sine is going to be radical 5 over 3. Now, how come we're not finding out the theta? All right, because you're doing arc cosine, that would get you your theta, and then you're doing sine of that theta, again, right away. So we're just going to use this to go backwards to draw our triangle, and then go forwards with the outside operation. All right, and these can kind of be tricky, these two last problems. Write an algebraic expression for x. We have secant of arctangent of x. Okay, secant of arctangent of x. So we have arctan of really x over 1. So opposite is x over adjacent is 1. Tangent is opposite over adjacent. So x over 1. A squared plus b squared equals c squared. And this hypotenuse is going to be radical 1 plus x squared. Kind of a confusing thing here. Okay. Secant is 1 over cosine, excuse me. 1 over cosine. So cosine would be 1 over the radical. That's cosine. So then secant would be square root of 1 plus x squared. It'd flip back up. Okay. We're a little offside there. Tangent of arc cosine of 2x. Okay, again, it's really 2x over 1. That's how we're going to treat it. It's positive 2x there. So we're going to go in quadrant 1. So cosine is adjacent over hypotenuse. So this is 2x. This is 1. So you have 2x squared plus b squared equals 1 squared. So then this other side here is the square root of 1 minus 4x squared. And then now to do tangent is opposite over adjacent. Over 2x. All right. There we go, folks.